So using our empirical rule, what we want to do is look at these different probabilities. So we're going to be working with that rainfall in Portland again with that mean of 40, standard deviation of 8. So we end up with this normal curve for our rainfall, centered at 40, standard deviation of 8. So what percentage of the time is the annual rainfall between 32 and 48 inches? So this is going one standard deviation below to one standard deviation above. And since we're looking for this percentage or probability, those words are going to be interchangeable, you want the area between those two values. That's going to be how we calculate probabilities here. So this probability of 32 being less than or equal to x being less than or equal to 48. Calculating this, we want the area under the curve. And right now we're just sticking with the empirical rule of that one standard deviation below to above is about 68%. So this is about 68%. So about 68% of the time, annual rainfall is between 32 and 48 inches. With our next one, what is the probability that the annual rainfall is more than 48? So 48 is at that cutoff of one standard deviation above, and we want the probability of more than that value. It means we'd be shading everything to the right here. So with this, we need to get kind of creative with how we're using the areas under the curve. Because based on symmetry, we knew we had the 8% about right there in the middle. And with bell-shaped curves, it's perfectly symmetric. So it's in this tail is also in this tail over here. So what we want to do is use the idea that this whole curve is equal to 1. So we have this 100%. If we take out that 68%, now we'd have the area in the two tails. So in the area in just one of the tails, if we take this total area between those two, we just need to cut it in half. And that would give us a 0.16. And to make sure, if we put 0.16 over here and 0.16 over there, we should just make sure it all adds up to 1 in the end. We have these two symmetric tails with that centered value, so you can just cut in half and get that single tail. So the annual rainfall is more than 48 inches, about. Then for what percent of the time is it 24 inches or less? So this is going 2 standard deviations below here, and we want this little tail right there. So if we think about our symmetry, if we cut on that side, we'd have 95% in the middle here. So we want to think about what's in the single tail here. So take your 100%. If we take out that 95%, that's telling you what's in the two tails. And then to get the one tail, just divide it in half, which will be a 0.025. The annual rainfall is 24 inches or less, 2.5% of the time. Again, just making sure if we had 0.025 in that tail and 0.025 in that tail, should all add up to 1. And this last one, what is the probability of 56 inches or less? So 56 is out here at 2 standard deviations away, and we want this area to the left of it. So there's a few ways to think about this one. Working with the 2 standard deviations rule, there's this 95% in the middle. As we just found from this one, there's 0.025 and 0.025 in each of the tails. So 2 ways to think about this one is you can either add these, take that 95% plus that 2.5% to get your 0.975. Or what you can also use is the complement rule, in that if we have this 100%, the only thing we want to exclude is that 0.025, and that'll give you the same answer out. So the annual rainfall is 56 inches or less, 97.5% of the time. So these work out nicely because we're landing right at 1 or 2 standard deviations away. But let's say I had said, what is the probability that the annual rainfall is 50 inches or less? And with this one, since we'd be landing in between, we'd have a harder time with this one. And this is where we're going to use GeoGebra. GeoGebra, we can plug in the mean and standard deviation for a bell-shaped curve as we want to along this number line in order to calculate. So the empirical rule is nice for these kind of quick calculations. Again, and I think I didn't put it on all of them, but it should be about. All of these are estimates here, and what we're going to do in GeoGebra next is going through this example, setting our mean and standard deviation, and recalculating those probabilities accurately. So this piece right here I'm actually going to do in a separate video for the technology. But what you're going to see in GeoGebra once you set it up is we get to this part where we're at a normal curve, we plug in our mean and standard deviation, which for us would be a mean of 40, standard deviation of 8, and then what we can do is using these buttons, this button here is going to make a left-hand curve, this is going to be bounded between 2 values, and this one's going to be the right side of a curve. You can plug in these different values for x, and your probabilities are going to show up on this right-hand side here. So go and look at the technology video for looking at those examples, but using GeoGebra.